All right, I wanted to give you more examples of factoring with the GCF, with the greatest common factor. So here are a few more. 9x plus 27y. Again, you're looking for what do they both have in common that I could pull out front. One thing that a lot of people do is they say, oh, well, 3 goes into both of those. And I would have to multiply by 3x plus 9y so that it makes 9x and 27y. Again, remember kind of the key to figure out that it does make the right result. But since inside the parentheses, 3 and 9 are both divisible by 3, that's a clue to you that you didn't get a high enough common factor. You didn't get the greatest common factor. So the greatest common factor is actually a 9, which I can multiply by just an x and then a 3y. That will make 9x plus 27y. And now when you look inside the parentheses, notice how those two terms don't have anything in common whatsoever. If I start 12x plus 18xy, and feel free to pause if you need to work it out and try it. 12 and 18 both have a 6 in common, and they both have an x in common. So we tend to typically only think of greatest common factor of looking at the numbers, but keep in mind, if they both have an x as a factor, that is something that they have in common as well. So then you figure out, well, I'd have to multiply 6x times 2 to get 12x, and I'd have to multiply by 3y so that it becomes 18xy. So it makes the right pieces. Inside the parentheses, they don't have anything in common. So if you had left the x in there and just done 6 times 2x plus 3xy, it does make 12x and 18xy. But the problem is if they both have an x, you're looking for them to not have anything in common inside the parentheses. If I go with 6x squared plus 9x. Take a minute to work it. You end up with 3x is what they both have in common. And you would have to multiply by 2x plus 3. So you get 6x squared, you get 9x, and inside the parentheses there's nothing in common. So you are correct on that one. If I have, let's just amp up those exponents a little bit. If I have 18x to the 5th plus 10x to the 3rd, 18 and 10 only have a 2 in common. And then we know that they both have x's, so I'm going to put an x out front. If you're not sure on this, you can just start with a plain x, see what you would have to multiply by. I'm going to go ahead and tell you that it's 2x to the 3rd out front is going to make it to where, okay, now I need to multiply by 9x squared and just a 5 inside so that I get 18x to the 5th, 10x to the 3rd. If you did anything less than x to the 3rd out here, then you're going to end up having x's left over in both of these. So you, again, it's got to multiply to make the right thing. But then in order to get the greatest common factor, you want to make sure that inside the parentheses there are no common factors left. If I throw in 14xy plus 9x, people tend to get really confused on this one. Give it a shot. The 14 and the 9 don't have anything in common, so this tends to stump kids. The problem is they do have an x in common. So the greatest common factor doesn't have to have a number. Sometimes the greatest common factor is just an x. I would have to multiply by 14y for the first term, and I'd have to multiply by 9 for the back term. It gives me 14xy, it gives me 9x. These don't have anything in common. So that is correct on that one. So don't get so focused on the numbers. Negative 35x squared y minus 42 xy squared. If they're both negatives, I'm going to pull a negative. That's something they have in common. 35 and 42 have a 7 in common. They both have x's, so I'm going to put an x out front. But you kind of start to notice that you're limited by whatever's lower. So x to the 1, that's all you can take out. And the same thing with y's. They both have a y in common, but you can't go any higher than the 1y. So I'm going to multiply this times a 5, and I need another x in there, but I've got the y. If I've pulled out the negative, that means this is now addition. I'm going to need to multiply by 6 to get 42. I have the x already. I have 1y, but I need y squared, so I'm going to have to multiply by another y. That's going to make negative 35 x squared y, negative 42 x y squared, and inside the parentheses, there's nothing in common between 5x and 6y. The last one, just so you have an example like this, is when there's more than 2 terms. If there's more than 2 terms, then you're looking for what do all 3 of them have in common. So 10 and 4 and 16 all have a 2 in common. That's as high as I can go. 4 doesn't go into 10, even though it goes into 4 and 16. So that's as high as I can go. The x situation, well, these two have an x, but that one doesn't have an x in common, so I cannot make it part of my common factor. Has to be common to all 3. And now I just figure out, okay, well, I need 5x squared to get 10x squared. I need negative 2x to make negative 4x. And I need plus 8 to make 16. And so now, it makes all the right terms. These inside, there's nothing that all 3 of them have in common. All right? Hope those examples help you out. On your worksheet, you do not have to do the last 3 problems. I think it's 16, 17, and 18. We didn't get to that method, and it's okay. We may circle back in and get to it later, but good luck. Hope this helps.